Section 9-3, Composite Figures. The objectives of this lesson will be to use the area addition postulate to find the areas of composite figures and to use composite figures to estimate the areas of irregular shapes. Okay, let's go ahead and define a composite figure. This is a plane figure made up of triangles, rectangles, trapezoids, circles, and other simple shapes, or a three-dimensional figure made up of prisms, cones, pyramids, cylinders, and other simple three-dimension figures. So here's an example of a composite figure, which you can see it's made up of a triangle here, a rectangle here, and half a circle, so a semicircle down here. So it's made up of more than one shape. Okay, let's go ahead and try this example here. It says find the shaded area. So the shaded area is everything that's in here. And if you notice here, we have a triangle and we have a semicircle, so half a circle. So we're going to have to find the area for both of these shapes, and then we're going to add them together to find the total area of the composite shape. Let's go ahead and start with the area of the circle. Okay, so for the area of the circle, the equation is pi times your radius squared. If we look here, this circle from here to here, that's the diameter, measures 4 feet. I only want the radius, which is going to be half of that. So the radius is 2. So I'm going to go ahead and plug that in right now. So now I have 2 squared, which is 4. And then we're going to do 4 times pi, which is 12 point, if we're rounding to the nearest tenth, 12.6. Now this right here is the equation for the area of a circle. Notice here we don't have a full circle, we have half a circle. So this area right here is not my area. I'm going to have to take this number and divide it in half, divide it by 2. That will tell me the actual area of this top semicircle. So 12.6 divided by 2 gives me 6.3. Okay, so right here, I'm going to go ahead and write this in blue. The area of this top figure is 6.3. Now I'm going to go ahead and find the area of this triangle down here. Okay, the equation for area of a triangle is base times height divided by 2. If I look here, and if I were to flip this triangle, this right here would be the base, which is 4, and this here is the height. So I'm going to plug that in. 4 times 5, which is 20. You divide that by 2, and you get 10. So the area of this triangle is 10. So now if I want the area of the whole thing, I just have to add these together. 6.3 plus 10 is equal to 16.3, and we're in feet, so this is feet squared. This is my total area of this composite figure. Example 2. Find the shaded area of each figure below. So here I see that I have this rectangle here, and the shaded area is just this part here on the inside. Notice this half circle right here is not shaded. Same thing over here. That means we're going to have to cut that part of the area out of this equation. So to start off, first of all, I want to go ahead and find the total area of this whole rectangle here. Even though it has some white space, we can go ahead and subtract that white space after we've done the area of the rectangle. So first, I'm going to do the area of a rectangle. Area of the rectangle is base times height. The base down here is 33, and the height is 16, and that comes out to be 528. Okay, so the area of this whole rectangle is 528. I do not want to include the area of these two semicircles. Now if I put both of these semicircles together, it makes one full circle. So I don't have to worry about dividing the area of the circle in half like I did in example 1. So let's go ahead and calculate the area of the circle. Okay, the area of the circle is pi times your radius squared. Your radius goes from the center of the circle to the outside to one point on your circle here. There's no information over here to help me find that, but I do have the height of the rectangle, which tells me that this whole length right here is 16, which would be the diameter. So to get the radius, I just have to divide that in half. So the radius here is 8 feet. And that's all I need to calculate the area of the circle. So we're going to do pi times the radius squared. 8 squared is 64, and 64 times pi is equal to 201.1. I have the area of the rectangle, the area of the circle. I only want the shaded region, so from the rectangle, I'm going to subtract the area of the circle, and that will leave just the shaded region behind. So I'm going to do 528 minus 201.1, and we get 326.9. And this is the area of the shaded region, so not including this white area right here. Okay, example 3, find the area of the figure. We won't be leaving this answer in terms of pi. We're going to go ahead and round to the nearest tenth. If we look here at the figure, I have 3 semicircles and an equilateral triangle. I'm going to go ahead and first solve for the area of the semicircles, and then I'll find the area of the triangle, and I'll add all of those pieces together so that I can get the total area of this composite figure. Okay, so here I wrote the area of the circle, and I put divided by 2 already because these are each semicircles. Once I find the area of one of the semicircles, I'm just going to multiply it by 3 because I have 3 semicircles. So right here, I need the radius. I'm told that this whole length is 10 inches, so the radius is 5. And once we get that area of the circle, we're going to divide it by 2. So 5 squared is 25 times pi divided by 2 is equal to 39.3. Now I have 3 semicircles, so I'm going to multiply this by 3. So my total here is 117.9. And these are for my semicircles. Total semicircles. Alright, next I need to find the area of the triangle. Alright, so for area of the triangle, that is equal to 1/2 base times height. I know the base here is 10, I don't know the height. We can go ahead and put in the height here, and we know that this height is going to be perpendicular to the base. If you remember right, for an equilateral triangle, all the angles are equal, so they all have to measure 60 degrees. And this angle right here gets bisected, so this is 30. We bisected with the height, the base of the triangle, so this is 5 inches. I need to know what the height is so that I can plug it into this equation, because all I know is that the base is 10. I need to know what the height is so I can calculate the area. You can use your properties of your 30, 60, 90 triangle if you remember that. But if you don't remember it, we can use trigonometry, and I'll go ahead and do that. Here we're trying to look for this side right here. If I use the 60-degree angle, this side is the opposite side. This is the adjacent side, so that means we're going to be using tangent. Tangent of 60 is equal to the opposite, which is x, over the adjacent. So when we do that, to solve for x, we just multiply both sides by 5, which gives us 8.7. Okay, so now I know that the height here is 8.7, and I can go ahead and plug that into the equation and get the area of the triangle. So 10 times 8.7 divided by 2 is 43.5. Okay, so this is the area of the triangle. I want the area of the whole composite figure, so all I have to do is take the total area of the semicircles and add that to the area of the triangle. We're going to do 117.9 plus 43.5. That equals 61.4. And we are in inches, so this is inches squared. Okay, example 4. Use a composite figure to estimate the area of the shaded area. It says the grid has squares with side lengths of 1 meter. So basically we can come up with any shapes that we want to find the area of this composite figure. I'm going to go ahead and start off here, and I'm going to start by drawing this triangle. Now there's more than one way you could do this. This is just one idea of how you could estimate the area of this shape. So I could draw a triangle, and I tried to get as much of the shape over here. And I could do that over here as well, there, and we can do one last triangle here. I have 3 triangles here where I tried to get as much of the area covered in here, and that can help me estimate what the area of this shaded figure is. So right here on this triangle, let's go ahead and call this triangle 1. So I'm going to mark here triangle 1. We have base times height divided by 2. The base of this triangle, if I use this side right here as the base, this is 4. And I'm going to make this the height, which is 2. 4 times 2 is 8, divided by 2 is 4. So this right here, we'll put 4 meters squared there. We'll call this triangle 2. We're going to use the same equation because we're still dealing with a triangle. The base, I'll go ahead and use this side as the base. This is 3, and the height is 2. So 3 times 2 is 6, divided by 2 gives me 3. So this measures 3 meters squared. The last triangle here, this line was supposed to go to here. The base right here would be 2, the height would be 1, we'll call this triangle 3. Base is 2, height is 1 divided by 2, so this is 1 meter squared. So if I add this together, 4 plus 3 is 7, plus 1 is 8, so you could say this is about 8 meters squared. And this is just a rough estimate. Okay, so make sure you know which equations to use for which shapes. You're going to need to know that and be able to recognize the shapes when you see them. If you have any questions, write them down and we can answer them tomorrow in class.